Okay, I'm going to go through a sample calculation using a student's data. Okay? And so this is actual data from a student in our class who loaned me their data. Okay. So I looked at their data and they said they saw yellow on sodium. I want you looking at your sodium chloride. And were you interested in the yellow? That's the very first one I want you to do. So they said they had 19 centimeters is where it appeared, but that's not how far away from our center axis we are. So we have to check to see if this is on the 50. If this is on the 50 mark, then I do 50 minus 19, and I'm going to get 31 for this length of my triangle. Now, they have, for their diffracting gradient is on 40 centimeters. So, I need to find my hypotenuse. Because I'm going to need my angle. Okay? To find my hypotenuse, we are assuming that this is a right triangle. So I'm going to go back to the Pythagorean theorem, c squared equals a squared plus b squared. So c equals the square root of a squared plus b squared. Okay? Make sure you remember your order of operations. So I have 31 centimeters squared plus my 40 centimeters squared into parentheses, and I'm going to get that the hypotenuse is 50.6 centimeters, which is a reasonable answer because it is larger than either one of the other two sides, because the hypotenuse has to be larger than the other two sides. Okay, now for my angle. You have to go back to SOHCAHTOA. Okay, so we have SOHCAHTOA. Sine, cosine, tangent. I'm going to do sine because I'm interested in this angle here. This is my opposite. This is my hypotenuse. So I have sine theta equals opposite over hypotenuse. Then I have to do the inverse of sine because I need to isolate that value. On a calculator, my inverse of sine looks like sine -1. And over here, so I have sine -1, parentheses, opposite is 31, and it's 50.6. Make sure that your mode is in degrees. So check your mode by clicking on mode, go down to the third one, highlight degree, hit enter, and now you're ready to calculate. So just do second quit. Then do second sine 31 divided by 50.6, and you should get a reasonable answer. So I'm getting 37.78. If you're getting a decimal, you're in the wrong mode. Okay, so if it came up 0.38 or something like that, I'm in the wrong mode. So I'm going to enter a new page. To find my lambda, which is wavelength, it is equal to d sine theta. And then I use a conversion because I need it to be in nanometers because wavelengths is measured in nanometers. I've done everything in centimeters. D is going to be 1 over n. And on your diffracting gradient, you would have seen it said 1 over 1,000 millimeters per line. Okay, or 1,000 milliliters per line. Well, I'm going to go ahead and give you the conversion for this one. Instead of making you do it, And I'm going to add a 0 to it to do the conversion, so that we can have everything on the same measurement. And my angle from over here was 37.78. And my conversion is 1 to the 7th nanometers over 1 centimeter. And so I'm going to punch that in the calculator now. And let's see here. Remember that to do E, you do second comma. And I get 612. The sodium is the only one that I'm going to give you an actual measurement for percent error. The rest of them you'll be checking on a chart to see if you're within the range. So for sodium, my actual measurement for my yellow is 589 nanometers. So I take my accepted minus what I found today. Remember, that's in absolute value bars, divided by my accepted value again, times by 100. To find my percent error. And you want to check to make sure that you have a reasonable range for percent error. If you're way off, guys, you need to redo it again. Okay? Because it means the rest of your numbers off for us as well. Okay. Times by 100. Boom! 4% error. So this group did a great job. Man, y'all make it tough to figure out who the impressive group is this week. Anyway, those are your calculations on how to do this. Split the load. Don't try to do all the calculations. You're going to be overwhelmed, okay? This is a great question, not on this Friday's test, but on the next test around. It's a great short answer question for me to ask, is to give you example numbers or data and have you do calculations and tell me if it's reasonable or not. Okay? So split the load, and on the next day in lab, I'll give you the mystery substances that you'll match up, and hopefully you're doing a good job with it. All right. Have a great day, and it's a great day to be a leopard.